Hello, I'm Lola Golden, a sports and exercise student at Basvic. Today I'm going to be investigating acceleration and deceleration and explain how they can be used in a sport and exercise science setting. Acceleration refers to the rate at which a system's velocity changes over time. Acceleration is measured in meters per second squared. The formula to calculate acceleration is acceleration equals final velocity take away initial velocity divided by time. Final velocity is the speed at the end of the period, initial velocity is the speed at the start of the period, and time is the duration over which the velocity change occurs. Acceleration is a vector quantity. This means that both magnitude and direction are considered. In athletics, a sprinter accelerating from a standstill position at the start of a 100-meter race demonstrates acceleration. If the sprinter reaches a final velocity of 12 meters per second at the 50-meter mark, starting from a standstill position, which is 0 meters per second, over 5 seconds, it would be calculated by acceleration equals 12 meters per second, take away 0 meters per second, divided by 5 seconds, which would be acceleration equals 12 meters per second divided by 5 seconds, and the final acceleration would be 2.4 meters per second squared. This would mean that the sprinter's acceleration between the 0 to 50 meter split was 2.4 meters per second squared. In cycling, when a cyclist is accelerating down a hill, they have an initial velocity of 0 meters per second at the top of the hill, and it takes them 6 seconds to travel down the hill. His final velocity was 18 meters per second. We can calculate the bike's acceleration by using this formula. Acceleration equals 18 meters per second take away 0 meters per second divided by 6 seconds, which then makes it acceleration equals 18 meters per second divided by 6 seconds, which gives a final acceleration of 3 meters per second. This shows that the bike accelerates at a rate of 3 meters per second squared. The positive acceleration shows that the bike is speeding up. Deceleration is simply negative acceleration. It is the rate at which an object's velocity decreases. Like acceleration, deceleration is measured in meters per second and is also a vector quantity, as it has both magnitude and direction. The formula for deceleration is the same as acceleration, so deceleration equals final velocity take away initial velocity divided by time. In football, a player might decelerate when stopping suddenly after a sprint. For example, a player is running at 8 meters per second and reduces their speed to 0 meters per second over 4 seconds. Their deceleration would be calculated as deceleration equals 0 meters per second take away 8 meters per second divided by 4 seconds, which would then be deceleration equals minus 8 meters per second divided by 4 seconds, which gives a final deceleration of minus 2 meters per second squared. In motorsports, when a race car slams on the brake to stop quickly, they decelerate. If the car is initially travelling at 30 meters per second and slows to 0 meters per second over 5 seconds, the vehicle's deceleration would be calculated as deceleration equals 0 meters per second take away 30 meters per second divided by 5 seconds. Deceleration equals minus 30 meters per second divided by 5 seconds, and the final deceleration would equal minus 6 meters per second squared. As deceleration is a vector, this means that the magnitude also needs a direction, for example, north, west, backwards, and so on. A velocity time graph is useful when wanting to visually represent the motion of a system and how their velocity has changed over time. The gradient of the graph tells us whether the system is accelerating or decelerating. A positive slope on the graph shows that the system is accelerating. As time progresses, the velocity increases and the gradient of the graph increases from left to right. A negative slope indicates that the system is decelerating. As time passes, the velocity decreases and the graph slopes downwards from left to right. The steeper the downward slope, the greater the rate of deceleration. The steeper the upward slope, the greater the rate of acceleration. For some sporting examples, the first graph shows a sprinter acceleration. The slope is positive, showing an increase in velocity at the origin, which is the start of the graph. The velocity of the sprinter is 0 meters per second. When the race starts, the sprinter has an initial velocity of 0 meters per second and moves to a final velocity of 10 meters per second over 10 seconds. Using the formula, we can calculate the acceleration by doing 10 meters per second take away 0 meters per second divided by 10 seconds, which would give an acceleration of 1 meter per second squared. The second graph shows a football player decelerating. The line slopes downwards as the player's speed decreases until they come to a stop. For example, a left winger had an initial velocity of 9 meters per second as he was sprinting down the line to reach the ball that was heavily passed to him. As he reaches the ball at the corner of the pitch, he has come to a stop so he can outskill the defender. This means his final velocity was 0 meters per second. It took him 4 seconds to decelerate and come to a stop. This means we can calculate the deceleration by doing 0 meters per second take away 9 meters per second divided by 4 seconds, which would give a deceleration of minus 2 meters per second squared to one significant figure. Thank you for listening.